This is lesson 1 of the last unit of our course, which is on probability. So we're going to start with some experimental probability here, and specifically some terminology that you'll need to know. So first of all, you will need to know what probability is. So probability is a measure of the likelihood an event will occur. Okay, so likelihood, another word for that that we will sometimes use is the chance. So a measure of the chance or likelihood an event will occur. A trial is one round in a probability experiment. Oops. I'm just going to go back and forth with colors here just so you can see the difference. An outcome is a possible result of an experiment. So you'll notice that in the definitions of each of these, you kind of see the other vocabulary word involved. So they're all related here. An event is a set of outcomes with the same result. So for example, if we were flipping a coin, an event would be all of, say, the tails. Okay, and the last thing here is frequency. So the frequency is the total number of outcomes for an event. So using that coin flipping methodology or example, this is just the amount, the actual number that, say, heads comes out or tails comes out of an experiment. Okay, so moving on from those definitions, it says, where is probability used? So I'm hoping that you can just kind of take a minute and try to brainstorm a couple examples of your own, because there are many, but some common ones. Probability is used in gambling, sports, even weather forecasts, right? What they're really doing is telling you the probability of it being sunny or the probability of it raining. Census data. So you might not know too much about that, but your parents fill out a form basically that answers a bunch of questions, and also things like any really statistic, right? But an example, specific example would be like accident statistics. So how often, for example, maybe how often or how likely you are to get into a car accident or a plane accident, anything like that. Okay, so probability is always a value between 0 and 1 and can be represented as a fraction, decimal, or percent. So this is going all the way back to our review. At the very start of the course, we talked about fractions, decimals, and percent. Probability uses all three of these. Okay, so if we just want an example, so a fraction, obviously 1/2 in decimal form, that would be 0.5, and as a percent, that would be 50%. Okay, so experimental probability. Obviously, we're going to be discussing a couple different times, or different kinds rather, but experimental probability is determined using the results of an experiment, which is kind of right in the name, right? Experimental probability is just probability that is figured out through an experiment. So we are going to need a formula for this probability. So the formula for probability, so P stands for the probability of an event is equal to the number of successful trials divided by the total number of trials. Okay, so again, it's kind of hard to understand until we do a couple of examples. So we will be doing 3 in this lesson. So first example, so it says 2 6-sided dice were rolled 20 times. Doubles were rolled 4 times. Determine the experimental probability of rolling doubles. Express your answer as a fraction in lowest terms, as a decimal, and as a percent. So we want to express our answer in all 3 possible ways. So we need to use that exact formula that we just wrote out, right? We need to know the probability of rolling doubles. We know that doubles were rolled 4 times out of a total of 20. So using equation, so the probability of doubles equals number of successful trials. So we were successful with doubles 4 times out of a total of 20 times. Okay, but we need to write this in lowest terms. So I'm going to divide my numerator and my denominator by 4. So 4 over 20 is the same as 1/5. Okay, but this also wants us to write it in a decimal and a percent. So to get to a decimal, all we have to do is divide. So for a decimal, we just need to do 1 divided by 5, right? That will give us 0.2. And as a percent, we need to take our decimal, 0.2, and multiply it by 100, which means that the likelihood of rolling doubles, or the experimental probability of rolling doubles in this case, is 20%. Okay, so we essentially have 3 answers here: 20%, 1/5, and 0.2. Those are all equivalent. They are all equal. The question says write the probability of not rolling doubles as a fraction in lowest terms, as a decimal, and as a percent. So again, we're just going to use that same equation. So this time, it's the probability of no doubles occurring. So we have to think a little bit more than the first one, but it's not too hard, okay? So again, remember on top, we need the number of successful trials. So in order to figure that out, remember we had a total of 20 and doubles were 4. So to figure out how many were not doubles, all we have to do is subtract. So the chances of, or the number of successful trials in terms of no doubles is 16. And again, the total amount of trials doesn't change, right? Okay, and again, we're going to divide here to get our fraction into lowest terms. We're dividing by 4 again. So the likelihood of not rolling doubles is 4/5. Again, to get that into a percent, well, I guess we have to do decimal first. Trying to keep my color coordination here. Okay, decimal, all we have to do is divide. 4 divided by 5, which gives us a total of 0.8. To get into that percent, we're just taking that decimal and multiplying by 100, which gives us 80%. And again, all three of these are equal, right? 4/5 equals 0.8 equals 80%. And again, that makes sense, right? Because 80 plus 20 gives us that total of 100%, which we need it to always add up to. Okay, moving on to example 2. It says a coin was tossed 30 times, so not 20 times, this time we're doing 30 times, and we have a coin. The experimental probability of turning up heads was 2/5, or 2/5. How many times did the coin turn up heads? Okay, so this is a bit trickier, right? So what we're going to do here is create a sort of equation to help us, okay? So we know that the total probability is 2/5. And we know how to calculate that probability. We have to take the number of successful outcomes. I'm just going to call it success, over the total amount, which we know is 30. So what we're really trying to do is just figure out this value here. Okay, so in order to do that, what we are going to end up doing, there's two different ways to look at it. So we can think about it as cross multiplying and dividing, or we can think about it as simply solving for our variable. So let me write this out, but have success as a variable. So we have 2/5 is equal to x over 30. So if we're just cross multiplying, that means we have to multiply these two things together and divide by 5. But if that is kind of a foreign concept to you, what we need to do is we need to solve for x. Okay, so we're just simply solving an equation. So we need to get x all by itself. So the first thing I need to do is get rid of this divided by 30. Okay, remember when we solve equations, all we have to do is do the opposite operation, right? So to get rid of that divided by 30, I'm going to multiply by 30. Those will cancel out. What I do to one side, I have to do to the other. So now I have 30 times 2 over 5, right? When we're dealing with fractions, any whole number that we have, we just put it over 1. We multiply the numerators, multiply the denominators. So 30 times 2 is 60, and 5 times 1 is 5. So 60 over 5 equals x. But if I divide those out, I will see that 60 divided by 5 is 12. Okay, so that means heads came up 12 times. Heads was flipped 12 out of 30 times. Okay, so for the first example, we were trying to find the probability. For this example, we were given the probability. Okay, so the next question says, how many times did the coin turn up tails? Okay, so we know that a coin only has two sides, right? So it has to either be heads or tails. If we know that there are 12 heads, all we have to do is take our total, subtract our heads to figure out how many tails we have. Okay, so our total was 30. Our heads is 16. That means our total for tails is, or sorry, where did I get 16? 12. Oops. Heads. 12. There we go. Gives us a total of 18 tails. Okay, and that's all this question is asking us. So we can just do a quick summary. Therefore, tails was flipped 18 times. Okay. Part C says, what was the experimental probability of it turning up tails? So again, all we have to do is use that original formula. So the probability of tails, we know that tails came up 18 times out of a total of 30. Okay, this is going to be equal to 3/5. Okay, so another way you could have found that is you could have, never mind, we're not even going to get into it because that's pretty easy and straightforward, right? So remember the top, the numerator is our successful flips, and the denominator is our total amount. Okay, so again, therefore, what the heck, that's not therefore, that's literally percent. Therefore, probability of tails is 3/5. Okay, last example. So example C, or 3, not C. Example 3. The results of rolling a 6-sided die are displayed on the graph. How many trials were there? So in order to figure out how many trials there were, we have to be able to read this graph, right? So the bottom, the x-axis, is telling us the number rolled, and the y-axis is telling us the frequency, which means the amount of times they were rolled. So what we need to do is we just need to add up the total of all of these bar graphs. Okay, so we have 4 plus 3 plus 1 plus 5 plus 3 plus 4, which gives us a total of 20. Okay, so there were 20 trials, 20 rolls of the dice. How many times was a 5 rolled? So all we have to do is we have to go to 5, go up to the top, and see that a 5 was rolled 3 times. Okay, find the experimental probability of rolling a 6. Okay, so again, we're just using that same formula. So probability of getting a 6 equals number of times we got 6 was 4. Total that we rolled is 20. If we divide those by 4, we will put it into lowest terms, which is 1/5. Okay, so again, therefore, probability of rolling 6 is 1/5. And lastly, last part of the note, find the experimental probability of rolling a 3 or 5. So this one's a bit more complicated, right? But it doesn't really change much. We're finding the probability of rolling a 3 or a 5. So again, we're using that same formula, so we need number of success over total number of rolls. Okay, so the number of success for 3 was 1, and the number of success for 5 was 3. So all we have to do is we need to add those together. Again, the total isn't changing, right? We still only rolled it 20 times. So the probability of getting either a 3 or a 5 is 4 out of 20, which we know is equal to 1/5. And again, just for good habit, therefore, the probability of rolling a, what was it, 3 or 5 is 1/5. Okay, and again, we should be able to put that into percentage, right? By dividing 1 divided by 5 times 100, because percent is kind of nicer for us to deal with. So that is equal to 20%. Okay, so you have to go to that decimal first and then multiply by 100 to get your percent. Okay, so this is the end of the first note on experimental probability.